and let her get started.
All right. Hello, welcome. Thank you for joining us. I am Danielle Klein. I am one of the teachers with Planet B Foundation. We are a nonprofit that focuses on sharing STEM lessons with grades K through 12. So we teach kids about bees and bees about kids. So our objectives today with this workshop is that to let you know who we are, to introduce ourselves to you, to give you a taste of our lessons. So we figured the best way to do that is to share our lessons as if you are our students. So we have 4 main lessons that we teach virtually, and we are going to walk you through those. Okay. We are also going to show you how we use STEM and integrate it into many areas of academics. So we are using Common Core and NGSS standards to weave into what you are already doing. Okay, as I said before, we are a nonprofit. We are San Francisco based. We are changing the world one bee and one student at a time. Our mission or our goal is to reach students using the bee as a friendly introduction to a green-minded mindset that will hopefully carry over and build a foundation that they will use in the care of the environment as they move through life, whatever path they go on. Okay, so that we are opening doors for students. We are truly dedicated to social justice, which means that our lessons are pretty much free, thanks to grants that we have received over the years. So myself and Deborah Tomaszewski, our founder and executive director, are here tonight, and she will be helping if there's any questions that you might have. Okay, and as we present our workshop, we are also including a link in the chat to kind of a notes document. So if you have any thoughts you'd like to share with us or any of the other participants, if you have any suggestions for us, we are always looking for new ways to reach students and classes. Please feel free to add to that document. It will be shared with everyone that is here or later on. So add anything you would like to say to us, or if you have any questions, you can add them there as well. But Deborah will be chatting as well to help answer any questions that you have, because we're going to cover a lot, so we may move a little quick. Okay. We use the bee to introduce environmental issues to students. Climate change, habitat loss, those are overwhelming and complex for adults, let alone students. So the bee is an organism that allows a friendly introduction in a kid-friendly way. And I know many of you are educators for older grades, but even still, it is a way to approach those issues that all students would be familiar with. So no matter where they are living, no matter what climate they are in, urban or rural, they're able to connect with the organism of a bee because they are everywhere. Okay, so we teach about honeybees as well as native bees. We have 4 main lessons, as I said. 2 of them focus on the honeybee, 2 of them focus on the native bee. So comparing those for students, the fact that our native bees typically live in the wild. There are more than 4,000 species in North America. The honeybee is the bee that you are more familiar with a lot of times as the honey-making bee that lives in a hive of about 50 to 60,000. So we make these comparisons for students to give some context to which we are talking about. Okay, our first lesson that we are going to take today a look at is our biometry lesson. Our biometry lesson is a math and science STEM lesson based on the honeybee. It is asking the question of, have you ever wondered why the cells of a hive are hexagon in shape? Is it an accident or is it a coincidence? Now, for some reason, I do have a slide that is showing standards that we use as we build our lessons. However, for some reason, Google is flipping that right now. But you will notice as we work through the presentation, there are boxes or squares on some of the slides. Those are indicating standards that that lesson covers. We have not included all of them as we do reach to hit many standards across a broad spectrum of academic topics. However, It gives you a taste of the idea that our program is developed to fit your curriculum that you are already using. So we are reaching the same standards of Common Core math, Common Core reading, as well as NGSS science and STEM standards. If you would like a full version of the standards that we hit, please let us know. We'd be happy to share it. It's also on our website. Oh, and there we go. So Google knew that I was talking about it and gave the slides back to me. Okay, so these are just a taste of the standards that you will see throughout the presentation. But our beeometry lesson focuses on the fact that bees are efficient. It focuses on the wax-making bee. And again, this is a honeybee lesson, focusing on the fact that their hive is hexagon in shape, their cells. But why is that? Is that a coincidence? Is it a happy accident in nature? So the students engage in the STEM mindset as we work through the engineering process and thought mind processes to make a claim and realize that it is actually a reason. We talk about efficiency with resources. We talk about the jobs that bees do throughout their lives that they are working. Many students find it amazing that bees start their work the day they are born. They do not like the idea that if they were a bee, they'd have chores right away. Okay, and we talk about the fact that bees need to be efficient with the wax that they make and all the hard work that goes into it, as we as humans need to conserve and be efficient with our resources. Now, the slides that I'm going to show you, we're going to go through them kind of quick as adults, but please keep in mind that with students, we work through this as a progression. We work up to the math that we are about to do. It is not just opened up at one time. So the students make a claim. We start out with, you may not have seen the cells in a hive, or you may have, but what shape would you expect to see inside of a beehive? Would any of you like to share your thoughts? And you're welcome to chat. Remember, you are our students tonight. Okay. So the students make claims. They typically name the shapes of triangles, squares, okay? And yes, hexagons, as many students do know what they are. But again, we need to investigate. Why is there a hexagon in the beehive? Why is it not a circle? Why is it not a triangle? We take into account that the hexagon serves many purposes for the bee. It has to interlock, it has to be strong, it has to store their survival needs like pollen, nectar, protect their brood. And then we get into the math. We get into the fact that, okay, these are the shapes that we are going to investigate. They are the most typically named shapes and considered. We work through gathering evidence on each shape, on each criteria that we have listed that the cells must do for us. We look at each of them individually as we decide, is there any wasted space? If you are a wax maker bee, you have to fill that space. Is that an efficient use of your time? We look at where we see these shapes in the real world. What purposes do each of these shapes serve? Looks like this rectangle shape is pretty strong and doing a good job until, no center support, not very structurally sound. Okay, we also look at triangles. You do see them in construction and architecture. Maybe they do have some strength, so maybe they are reaching some of our points, but as we work through our list, we saw for area and perimeter, we find the measurements of some shapes that are proportionate to each other. We work through the hexagon, the triangle, the square. At this point, we have crossed circle off of our list because of the wasted space and the fact that they do not interlock tightly. Okay, with the middle school and high school students, we get into area. We leave that out of elementary as it gets a little complicated with the formulas used for the triangles and the hexagons. And we're going to double these slides, but that's okay. You get a second glimpse at the wonderful math that we do. So here we are at area with the equilateral triangles the hexagons. Again, we work through these formulas step by step with the students. We work through the progression of how to get to the final answers. These for you are just showing the results. As we work through our investigation, we find out that the perimeter of the shapes as well as the area is only part of what we must consider. If we consider how many walls each shape must make. So as we get to our grid of shapes, we can see that we get to start saving on sides. Our squares here, only once do we have to make 4 sides. The rest of them, because they begin sharing sides, are able to save us some wax. So the students are able to see that with 3 rows of squares, we would need 59 sides. For the same number of triangles, we would need 43. For hexagons, 81 sides. Doesn't seem very efficient until you find out that using the areas and perimeters that we calculated, you may have to make 81 walls for a hexagon, but due to their size, they are shorter walls, which allows you as a wax maker bee to actually make less wax for a proportionately shaped space to store your honey, your nectar, your brood. So it is not a happy accident that bees use hexagons. So again, this is a progression that we work through with our students as they solve the math, work through the problems, check off our list, and see which shapes work. There's a picture of our baby that is going to grow inside of the shapes. This is showing what that would look like as far as wasted space. And yay, our hexagon has won. It is the bee's favorite shape. It is efficient for the wax maker. It serves the purposes. It is very strong. It's been working out. It stores everything we need, and it shares plenty of sides that allow us to save on wax. We take a look at real-world examples as we work through all of them to give context to students that may not have seen a hive up close. Okay, any questions about beeometry before we move on to a taste of our next lesson? Okay, our next lesson is do the waggle. Okay, so this lesson is again a STEM lesson integrated across multiple academic areas. It covers things like reading standards such as being involved in group discussions, doing research, sharing ideas, comparing, contrasting, making connections. We work on STEM standards as far as math and science with communication. Okay, so how do bees communicate and what do they talk about? What are they sharing with each other? So our waggle dance lesson works on communication. We always like to start out by making comparisons to students to give context, again, with the fact that humans communicate as well as other animals and organisms would not want to run into that snake in the middle. And bees, of course, communicate. So as we build the context and work into the bee, again, our bee is a vehicle that allows us to introduce many STEM concepts to students in a friendly way, and it's easy to focus on. So bees use their antennas. Do you have your antennas? Share a message with your friends. What would you like to say? What would you tell them? Hopefully you would tell them that you are enjoying the presentation. Okay. But our bees communicate about many different things: moisture in the air, wind speed, air quality, temperature, food, and of course, the food. What do we as humans like to talk about? What we had for dinner, where the best restaurants are. So do the bees. The bees like to talk to each other about where they found that best patch of flowers, where the tastiest nectar and honey is going to come from. So as they are discussing this, bees, they can't just pull out a map. They don't have Google to give directions. They're not using their GPS. So how do they share that information? If you are a bee, how do you tell your friends where the best patch of flowers is? You do the waggle. The waggle is based on distance and direction. Imagine if we had to dance for our friends every time we wanted to tell them something really cool. The bees do. So during this lesson, students work on angles, they work on measurements as we compare the angles to the sun, that is the bees' relative point, that they relate their flowers to. So we learn directions, we work on at angles as far as not only what the angle is, but what direction it is pointing, as well as measurements of distance. So as we get in, with the older students, we're able to actually talk about degree measurements of angles. We are able to compare distances, but we use this hump or this wiggly line as just a visual representation of every second a bee waggles is a kilometer of distance from the hive. So the longer that a bee waggles, the further the food is. So we work through a series of math calculations as to where the bees may have found their food, interpreting their waggle dance. Which direction did they go? Okay, the fact that a kilometer is the same as 3,280 feet. Bee doesn't have enough, but there's a friendly centipede willing to lend a few. Okay, and for your enjoyment, everyone likes to see a waggle. If you watch the bee in blue, that bee is sharing some information as we speak about where they found some good food. Okay, so this lesson focuses on that forager bee, the bee that actually has to venture out into the world. It is the last job that a honeybee does in their life. It is the most dangerous job, so they are our fearless leaders of the beehive. And we're going to watch it again because that bee has a lot to say. All right. So again, looking at angles, looking at directions, comparisons, bees travel, they keep in mind, so if you're a bee flying to your food, you're going to pay attention to which side of you the sun is on. And as you waggle, the angle is telling the other bees, the other foragers, the relationship of your flowers to the sun. So it is a very abstract concept for students. The older students are able to connect with those angles and directions, as well as think outside the box a little bit of how if they were the bee moving towards the sun and away from the sun, what that would be like. You have to find the food. Okay, so this bee, as you can see, has waggled for 5 seconds or 5 kilometers in a northeast direction. But our students work through a variety of math problems as we figure out who is waggling correctly. And what are the waggles for? What's the purpose? What does this nectar and pollen, why are we gathering it? To make honey. So we also learn a little bit about honey is made and the fact that honeybees dry out or evaporate the moisture from the nectar that they collect. And to make the honey, guess those bees didn't want to play, but there you go. Okay, so you can see them, how fast their wings are beating, how fast they would have to go to be able to create the necessary reaction to create honey. Okay, any questions about doing the waggle before we move on to the taste of our next lesson? Will you be waggling when it's time for dinner to tell your family to come to the table? Yeah, I think our family, I'm in Pennsylvania, so we had dinner this evening. But that is, a fun way to call the kids to the table, direct them which way to find their food. Okay, so our next 2 lessons focus on the native bee. This lesson is Wanna Be an Engineer, where we get into the fact that the engineering mindset works through a process of problem solving. This is our conservation-based lesson. Again, it is integrating STEM and mathematics, reading on many different levels. Our lessons are geared, we have multiple presentations. They reach from K to 12 in an age-appropriate way. Our Wanna Be an Engineer focuses on the native bee, as well as comparing. We get asked a lot, what is the difference between a bee and a wasp? Is that yellow and black thing bugging me at my picnic a bee? Are those honeybees trying to get me? Are those native bees the mean ones? No, they are not. So as the older students are able to work through the process of elimination, looking through the different characteristics in a dichotomy chart to see and narrow down for themselves the differences between the bees and the wasps. To finally give the bees a break and see that they are not the ones that are bothering you. Okay? We talk about anatomy as we decide what makes a bee a bee. What characteristics do they have that allow them to be part of the insect species, as well as what biology is helping them to do their jobs. Now, remember, our native bees are our bees that are native to North America. They have been here from the start. Our honeybees were brought from Europe for the purposes of pollination and honey making. Native bees have been here, and some of them are, well, they're all amazing, but some of them you would not even recognize as a bee. So the colors, the vibrancy is pretty spectacular when you get into looking at the different species. As older students, we are able to recognize that there are about 6 families of native bees in North America. We take a quick look at what they are, and as you can see, it is a wide variety of characteristics that group these bees. You can see the colors, the body styles. As we get into the next native bee lesson, we look at adaptations, but you can clearly see the differences here. So this opens up a wide variety of conversation with our students. Okay, and as we narrow down from not only the 4,000 species to the 6 families, we focus on our 4 main bees. We've chosen these out of the species because they are recognizable. They're easily seen. We teach classes all over the US as well as some Canadian classes. So we have chosen bees that at least one of them you can find in your area. So we have our leafcutter bee, we have our mason bee, we have our carpenter bee, and our bumblebee. It is fun to take a look at what they pollinate for us and what they do for us. Many students do not realize how much we as humans rely on bees, how much our food sources, not only our apples and things, but even almonds, onions, potatoes. I myself love French fries. I could not live without potatoes. I happen to live in walking distance from the Utz potato factory. So we have lots of potatoes where I am, and I'm very thankful to the bumblebees because they're the main pollinator of potatoes. We have, after taking a look at not only what the bees pollinate for us, we have a discussion of their nesting material. So our native bees are not living in the hive boxes that you commonly see or in a large hives with a swarm of 50 to 60,000. Instead, they are living solitary lives, except our bumblebee. Bumblebees will accept up to about 100 roommates. Still nothing compared to the honeybee. But they like a wide variety of nesting material. So pay careful attention. There is a quiz in a minute. Our leafcutter bee resides in tubular spaces, using those leaves that she lovingly cuts to cap off her spaces, her nest, and protect her young. Our mason bee, much as you may think of a human mason working with mud and bricks and clay, our mason bee relies on mud for nesting material. Our carpenter bee, again, relating it to the human context, a carpenter working with wood. Our carpenter bee uses their very strong jaws to chew holes in wood and nesting in wooden surfaces, which often sadly gives the carpenter bee a bad rap. They are not destructive. They are not termites. So please don't make the mistake of using pesticides on them. Once they have finished with their nest, they will leave. You can plug it up. So our carpenter bee uses wood just like a human carpenter. And our fuzzy bumblebee, who doesn't love a nice chubby bumblebee, they like leaf litter as well as underground cavities. They will even use spaces abandoned by other insects. Okay, I said there was going to be a quiz. Can we match them to their habitats? So we have spaces A, B, C, and D for bees 1, 2, 3, and 4. Which bee would live in space A? So you can chat to me, or you can hold up a finger. Sometimes our students, lots of finger holding up and counting. Who would live in space A? Would it be number 1, number 2, number 3, or 4? Yes, you are correct. It is number 4, our carpenter bee. That is what their wooden chewing space may look like. Space number 2, pay careful attention. B and D are pictures taken from the same native bee house, but pay careful attention to what is capping those tubular spaces. The color gives it away, especially. But in space B, who would live in that tubular space stuffed with that green material? Okay, so again, you can chat. Yep. Number 3, our leaf cutter bee. She has worked very hard to trim those leaves, roll them up, and stuff them safely. You obviously have your listening antennas on tonight or this afternoon. Sorry, time difference. Okay. Bumblebees. We have our bumblebee and our mason bee left. Space C. Who would live in that shaggy grass, that dark cavity space in the ground? Who would call that home? Yep, number 2. Absolutely. That space would make a bumblebee happy. They like the cool, dark ground. Okay, and finally, space number 4, again, a tubular space stuffed with a brown material. Who would live there? Yes, number 1, our mason bee would be very happy to call that home. So great job listening as we studied their habitats. Thank you for having your listening antennas on. Okay, so with our students, we watch a video. And one of the reasons that this is an engineering lesson is because they actually get to engineer or build. We watch a video about how to construct a native bee home out of found or reusable materials. And while we have the lesson, if students have materials on hand, we go ahead and roll some tubes and work on our house. So if you have a piece of paper, you are welcome to roll a tube, but these are just some screenshots from our actual video that we share with the students. It's encouraging them to reuse materials such as those plastic bottles that they might throw out, as well as their paper grocery bags. We cover topics as far as placement of the house. They need to be protected from the weather. We also cover hygiene. We find out that bees do not take showers and wear deodorant. We have to keep them clean by cleaning their home for them, replacing those tubes. Okay. And we talk about how they can use that supplies, and it also encourages responsibility for the environment, starting to look out for those native bees in their area. And what goes on? Life inside of those bee tubes, what is it like? There is a space here, or pictures here, of our female bee at the bottom, our leaf cutter bee. You can see her material stuffed in there. But the larvae get about an inch of space, so roughly 5 or 6 larvae will fit in a tube, because on average they are about 5 to 6 inches in length. They are tucked in nice and tight with some bee bread, which is a mix of the pollen, nectar, and some good old mama bee saliva, which the kids always love to talk about. The fact that how did that saliva get there? Well, mom spit it out. So imagine if your food was what mom spit out. So again, it encourages some interesting discussions with their students, keeps them excited. But with the older students, we can look at the fact of what actually goes into these materials, the consistency of them. But this is what life inside of a tube looks like. But does it matter? Making these bee houses, using these found materials, Is it really worth it? How much help can one little bee house provide? Actually, quite a bit. Again, you're seeing the answer sheet, as teachers always often do. The students work through the math. But in a 6-inch tube, a mason bee female can lay roughly 6 eggs. In a bee house that holds about 100 tubes, you are helping about 600 larvae. If each of these larvae grow to an adult that pollinates roughly 2,000 blossoms a day, 5 days a week, we work through how many blossoms each of them is growing, because that is roughly 42 million blossoms pollinated by the larva from one bee house. So instead of throwing your water bottle away, make a bee house, because those blossoms may just be some of your favorite foods. And the mason bees that we're using in this example are extremely efficient pollinators because they are naturally ungraceful. They belly flop onto plants, which allows them to have more pollen stuck to their bodies, which as they move from plant to plant, they move more pollen around as they continue to belly flop, and they might be helping in an orchard near you. With our older students, we work on the fact of how far bees can fly. A bee can fly up to a rate of about 7 miles an hour. If they are traveling different distances, 6-mile round trip, as a bumblebee will often pollinate up to 3 miles from their home, meaning they have 3 miles out and then they have to get home. So what does that look like as far as how long is that bee taking to make those trips? How much time of their day are they spending actually pollinating? So again, another math inclusion as we work through learning and appreciating our bees. And imagine if you had to travel 6 miles every time you wanted a snack, because that bee is going there to eat. I would definitely not want to have to travel. I probably think twice before a snack, which would probably be good, but you can see the amount of time that bees are helping us throughout a day, a week, even a month. Now, this is one of our favorite challenges as students. You've been using your listening antennas very nicely, but can you use your wings? How fast are you? We show the students a video that shows them how fast a bee's wings really flap, and it's even a slowed down video. But in one clap, 1 second, a bee has flapped 200 times. In 30 seconds, they would flap a lot, and we'll look at that in a second. But how fast can you flap in 30 seconds? So your wings have been resting, should be good to go. We'll put them up, stretch them out for a second. Okay, I'm going to time us as we flap. Can you keep up with a bee? We will all look a little goofy for a moment, but that's okay. It's some good exercise. And ready, set, go. You're going to go faster, faster. Keep going. You're not getting up to the bees yet. I think bumblebee just passed us. And 10 seconds. Don't give up. And stop. Okay, so even the older kids appreciate the exercise, the chance to move, and the silliness of it all. But how many times did you flap? You are welcome to chat to me or share your answers out loud if you would like, but how many times? And with the students we fill in the graph, you always have some that say they make it to 90 and are pretty impressed with themselves until they find out that in that same 30 seconds at 200 flaps a second, a bee is about 6,000. So most of our students, and myself included, are in the 30 to 40 range. But it's a fun time to see if we could keep up with a bee. Okay, then we take a look at our pollinators and how they affect our food. So taking a look at our food pyramid, what foods would we lose? Anybody want to share? If we could no longer rely on bees to pollinate, what would our food pyramid look like? How would our diets be affected? How would our health be affected? We need to eat a rainbow, as they say, to have a full range of nutrition, what would it look like if we could not count on the bees? Anybody want to share something that would be missing? So would we have all of our fruits and our vegetables here down here in the middle? Yep, we would definitely lose our vegetables and fruits. Okay. We would definitely lose our tomatoes. And when you start telling a student that they're going to lose their vegetables, they don't think that much of it until you start pointing out that those fruits and those vegetables go together to make things like pizza. Then they start recognizing the importance of it. Down here with our grains, many of them we could keep on the fact that grains are wind pollinated. However, they wouldn't taste the same for us. We are used to eating our foods with ingredients that we don't always realize are in there. And some of those secondary ingredients do rely on the bees. For example, in our ice cream and our dairy, many ice cream flavors, not just vanilla, rely on the sweetness of vanilla. Vanilla is pollinated by bees, so chocolate is not. And yes, your cows would still be there to provide the milk, but it would not taste the same. Even some cheeses are flavored with things that rely on bees. Okay, and our meats, we would lose a lot of our peanut butter, our almond butter, things like that. And our top, even our mayonnaise would be gone. Many mayonnaise brands rely on oils that come from olives or other things that are relying on bees. So really makes you think of what your diet would look like, what your food choices would look like going out to a restaurant, although it's already not the same for us, would definitely be even more different if we lost our bees. Okay, get my mouse back. So it's okay, it's not all lost. We can help the bees by planting a garden that will help them with their pollen and nectar collection and help us. You can plant a garden with some of your favorite foods to help the bees. And with the older students, we are able to actually work through a grid of the idea of in a certain space, what plants could we fit? What choices would you make? How would you help the bees? Anybody want to share what they might include in their garden if you planted one? Some of you may have one. I personally love to plant watermelon, and I love to plant, we have blueberry bushes. Okay, and even the nice thing about this activity too is that it's able to encourage students that are even in urban environments to plant or consider plants that they could grow even in a small limited space, even on a balcony or a patio in a pot. But again, it's not only helping the bees, so these really things help students to feel empowered that their decisions can make an impact. Yeah, zucchini, basil, those are good. Strawberries, blueberries, lemons, yes. All good choices that bees love. Okay, so any questions about wannabe before we take a look at our fourth and final lesson? Okay, so our bumblebee friend has bundled up because in our next lesson, we are taking a trip to the Arctic. Adaptability focuses on adaptations by looking at the trip or the life of a bumblebee in the Arctic and how bumblebees are able to survive in a wide variety of environments thanks to adaptations. So again, we look at the context of, we do a lot of vocabulary building, okay? And we also recognize that some of our students are coming from different levels and learning, so we strive to reach students where they are so that they can learn and enjoy with us. Lots of visual cues as well as written and oral language. So we look at the context that our humans have adaptations. Right now, if you have an object in front of you, you can try to not use your thumbs. As humans, We have an adaptation of thumbs that we appreciate and often take for granted, but our poor puppy dog that doesn't, we always tease my dog about the fact that she doesn't have thumbs, that tried to pick something up without using your thumbs. Can you do it? It's hard. You can, but it's hard. So again, life would not be the same without our adaptations. But what adaptations do bees have? How do animals in other areas adapt? Again, we like to build context with not only humans, but other organisms our students may be familiar with. We look at the fact with the older students that there are both structural and behavioral adaptations that often play hand in hand in the survival of many species. Again, building our context as we work to our bees. How are these bees adapted? Anybody want to share anything they might see or notice? Again, these are native bees with a variety of climates and habitats. What's different about them, or what's alike? How are they surviving? They don't have an elephant trunk like our elephant. Yeah, the colors. So the colors provide them with their camouflage that often has to do with what flowers they are visiting, allows them to blend in while they are there. Yes, the fuzziness absolutely is part of that. We're going to take a closer look. Okay, so these bees are two actual species of bumblebees, though one is very hairy and one is not. So we open up a discussion as to why that may be. Our hairy bumblebee is able to carry pollen in one way by having it stick to its body, where our bald bee is using a crop, an inner organ, to carry its pollen. However, they are both using their adaptations to serve the same purpose. Our bee is not able to take a bath, but thankfully, it has adaptations that allow it to remove its pollen. But why do bees buzz? Any guesses? It's not an accident, as we learned with our hexagons. Nature has a purpose. Warmth and, whoop, sorry, my slides are getting ahead of me. Bees buzz for warmth and food. So as you can see, this bee is buzz pollinating. Buzz pollinating allows bumblebees to reach pollen that even other bees cannot reach. Their vibrating and buzzing on a flower will release pollen deep within a flower that even the bee with the longest legs or proboscis is not able to get to. So certain flowers are geared for certain bees. It also allows for survival of many species within the same area. So they are not fighting for resources. But we're going to focus a little bit on that warmth. How would a bee survive in a place like this? I know it would be hard for me to survive in a place like this, although sometimes my backyard does look this way. They need sun. And we talk about the environmental benefits of sun for all organisms, as well as the fact that bees rely on it for the temperature. We look at fractions and various types of math as we work through, again, our math problems to get to the conclusion of whether or not a bee can fly each day. This poor bee met a day that did not have enough sunshine. But thankfully, other days, even in the Arctic, there is enough sun that bees can fly, be active outside, pollinating and foraging. However, it doesn't just rely on sunshine or the length of sun, also relies on temperature. Okay, so again, we work up to these math problems and things through different progressions with our students. I'm going through them more quickly than I would with a child of any age. Even our older students, we have lots of graphs that they look at in this lesson. This lesson is packed with lots of comparisons of numbers. But a temperature for a bee needs to be around 86. We, as humans, like our body temperature, are normal to be around 98. A bee wants theirs to be around 86. It's not always that warm though, especially not in the Arctic. So they are able to raise their temperature by buzzing. Again, that adaptation that helps them with their pollinating as well as staying warm. So by buzzing, a bee can raise their temperature as much as 60 degrees. They do not always go 60 degrees, but they have that ability. So that their temperature after buzzing can reach 86 or above on days that the air would be too cold on its own. So we're able to work through a variety of math problems with students and look at a variety of days. And how does buzzing raise their temperature? It's activity. So you, after you exercise, feel warmer, you sweat. Bees, as they buzz, they are circulating their blood at a faster level. They are able to warm themselves just like you would running on a treadmill. So with that warmth, it allows them to, again, forage and pollinate in climates that they may not be able to otherwise. And is it the wings that make the buzzing sound? Yes. The sound you're hearing is kind of like an after effect of the fact that they are moving so quickly. So their wings are flapping at such a high rate as they're vibrating and rubbing against each other, you hear the sound. But for them, the sound is not really a benefit, it's just secondary. But it helps us to know when they're around. So again, this bee really, really, really wanted to fly, and it buzzed its hardest and it raised its temperature as much as it could, but it's not going to be able to fly today. Poor bee has to stay home. However, again, even in the Arctic, there is hope. There are days that the bee can buzz and fly and be active. It can go find its favorite food. We also tie the fact that these adaptations do not happen overnight. They are handed down generationally from adult to offspring. We look at the fact that bees have evolved over time as they become what we are used to seeing them as. We talk about the fact, and especially with the older students, we're able to look at a little bit more of that genetic progression. As we tie all of our lessons into the fact that not only us as humans, but other organisms are relating to these bees and relying on these bees for harmony in their ecosystem. How are all of these very, very different organisms connected? They are relying on the sun, they are relying on the water. Students love this part, even the older ones. When they're able, we let them annotate to find the connections, but it connects everything. And by the end, our screen is colored, and it proves the point that even if one organism's not eating the other, the bee is pollinating habitat for the other insects, providing food. We love to talk about students that they often ask, what eats the bee? And one organism that does like to snack on bees is a skunk. So that often can open some other discussions too. But in the ecosystem, we are all connected. So not only do we need our bees, we need to protect our bees and our environment for benefits that we may not even notice firsthand. And how can we do that? Through a variety of things like shopping at local markets, educating our friends, saving some of that leaf litter behind in your garden for those bumblebees, or creating a garden to give habitat, skipping the chemicals and pesticides, and working with your friends to build bee houses. So again, I hope you have enjoyed our presentation. I know we have a few minutes left, so we will have time for any questions. But we are Planet Bee Foundation. We thank you very much for joining us and hope that we get to see you again soon in your classrooms. Again, our programs are offered, thankfully, to very generous grants at very little to almost always no cost. And our materials will be available to you. For joining us today, you will be able to access our online materials through our online classrooms to do some research with bees for yourself with your students. We have great video lessons that you can do with your students, as well as you can sign up or register for one of our virtual lessons where one of our educators, like myself, will join your class to teach about bees, and we will do the full length of one of these lessons. But if you have any questions, myself and again, Deborah Tomaszewski, who is our founder and director, is here. We are happy to answer any questions that you might have.
And I'm just going to turn off the recording for now.